Amir, thank you for joining me on the podcast.
Of course, excited to chat.
Yeah, we got connected with a mutual friend as we were discussing before we came on. Got tagged in a post, and it seems like you're going on a little podcast rampage. I'd love to hear a little more about who you are and what you do. Could you introduce us?
Yeah, for sure. So I'm Amir. I'm originally from Iran, came to Canada in 2008 to do a PhD in quantum physics. So I wrapped up that in 2014 and went to England to work at the University of Oxford for a few years, and then decided that academic life wasn't exactly what I was looking for. So moved on and started looking for roles in industry. First, tried starting a quantum tech company because that's what I knew pretty well. But there wasn't enough market for that really back then in 2015 ish. So I decided to move to the next best thing that I knew, which was AI. And a lot of physicists were moving to data science and such. So came back to Canada and I started working as a data scientist and sort of started going up the corporate ladder relatively fast. Ended up being a manager, product manager within 3 years, and built a product that we used at the bank. Um, Along with that, I started building a community in Toronto, a bunch of nerds, I like to say, and eventually, started a company out of that community. So, just a very quick background.
Yeah, I love that because I think there's been a lot of talk about PhD candidates and professors or such instead of going the chasing the tenure track, leaving academia and taking that knowledge into the startup world. There's a few professors have been talking about this. It's like the brain drain from the academic side because it's like why spend this sluggish long battle of building your credentials in the academic field in order to get this only a few tenure slots that you get when you can capture that take all everything you've learned, especially that specialized knowledge that you've gained, and take it into the tech realm where you can grow really fast. And if you acquire the right set of skills, create your own firm where you can scale and develop and build. And that's becoming the new way of developing knowledge now, right? Like you, rather than working within an institutional environment and taking use of facility resources, you can now and go and obtain your own and still somehow access them if you go to the right incubator networks and etc. So I love to talk
Oh.
about that little transition, leaving academia, especially in physics, right? So
Mhm.
physics is generally, I'm assuming you did more applied physics rather than theoretical.
That's right.
Could you
Yeah,
talk a little more?
definitely.
Yeah.
Yeah, for sure. So what you described is exactly what happened. The morning that I woke up and I was like, this is not the life I want, was the morning after I submitted my first serious academic grant application. I was working at University of Oxford. There were a lot of very, very smart people there. And as soon as I submitted this thing, I was like, there's no way I get this because there are a lot of people who have submitted in my own lab who are smarter than I am, and I'm competing with this level of people. Like, that's just the top tier scientist in the world, right? So, and the whole academic system and value exchange that exists in academia is all around, very, very extreme competition to get like a very, very few available positions. So, what I thought at the time was exactly what you said. If I'm going to compete at this level, I might as well do it for a project that I personally care about and can make a lot of money out of, right? So, and over the past few years, as I went to corporate world and then moved into my own company, a very, very interesting thing that started happening is that I started getting access to government grants and hire PhD students and postdocs to work for me. Like right now, I have a little research group, mostly at the University of McGill, in collaboration with a prof there. Two postdocs, a PhD student, a couple of master students, which is what I would have probably had in academia as well, except that they're working on my ideas, researching my ideas to help me build a product that is a commercial product, right? So drastically different mindset, drastically different environment to apply the same skill set, uh, but a lot more control over what is going to be outcome versus I'm doing all the above to just get the next paycheck.
Yeah. So, I mean, coming back from that academic background, could you talk a little bit more about your work in physics and the um, type of work you've done?
Yeah, definitely. So I was an experimental physicist. I worked on quantum computers, which is what a lot of people are chasing these days. So as an experimentalist, I was working in a lab, which means that I spent all of my days pretty much developing theories and exploring different types of theories, and then going to the lab and trying to actually do them and see what happens. So a lot of electronics, a lot of lasers, a lot of data collection and analysis, which ended up being the skill set, the part of my skill set that I ended up using in data science and machine learning later. A lot of writing code and analyzing various types of things. Um, but my project was mostly around um, essentially one specific type of quantum computers that people are still working on. So we wanted to show on a very, very fundamental level that kind of quantum computer is plausible. Like that was essentially the problem statement. And that specific type of quantum computer is one that works with lasers. So essentially, we wanted to show that you could use some variation of lasers to essentially do computation, like the way we do computation with CPUs and such. Imagine that all of this is replaced with laser light, and you can still do computation. And the precursor to that idea is the fact that for communication, we are currently using lasers, like all of these fiber optics, telecom networks that we use are the communication part or preamble of the same sort of idea, except that it also takes it a little further, and the physics of computation will be different. But very, very, very high level. That's the sort of research project I was working on.
I love to, the inner nerd in me is super curious about this because quantum computing used to be a top of mind subject, right? Like Google is competing in this space, like Microsoft's competing in space, and they're funding all these projects. And it seemed like we're just a 1 year away, 1 year away. Like every year there was an announcement that quantum computing is going to be here. It's going to blow away blockchain and make it redundant because computation is going to go up. And then suddenly we stopped hearing about them. Could you talk to us a little bit about, first, I'd love to learn a little more about how lasers are used in computation and how that's different from CPUs.
Yep.
And then what is the current state of quantum computing?
Yeah, definitely. So, I mean, I should put out a disclaimer that I have not worked in that space for the past 6 or 7 years. So my information is probably a little outdated. But quantum computing, like any other new exciting toy that we find, goes through the hype cycle. So definitely every time that there is a breakthrough, we get excited and we start doing interesting things. But that hype cycle is going to crash at some point, and then more established kind of applications and use cases are going to show up. So and that's exactly what happened. The first time people started talking about quantum computers was 3 to 4 decades ago, and over this time we've gone through many different small and large hype cycles. And I think the biggest hype cycle was the latest one, where a lot of VCs got really excited about it. They threw money at it. A lot of, like, even Creative Destruction Lab in Toronto had or maybe still has a quantum stream where they were, I don't know if that's the right word, but pumping out quantum tech startups. So but out of a lot of those startups, and when I was leaving academia, my point of view was quantum alone is not going to be the solution. Like, you have to combine it with something else, because we don't even have the hardware to do it properly. Like, if we go to any customer and say, you have a quantum computer, the first thing they're going to ask is, what's your use case, right? What can you help me do better? And I can't say there are these theoretical ideas, like they want to test it tomorrow. So I always looked for overlaps of quantum ideas and other ideas. And the successful quantum companies that we see today are exactly like that. They are using quantum plus machine learning plus biology to do drug discovery. Or one of my friends is doing a very interesting company where he's using quantum ideas to improve the efficiency of MRI. So longest story short, what I'm trying to say is that the hype of a general computer has settled down a little, and people started finding more interesting use cases where an overlap of quantum ideas, or even quantum inspired ideas, and other types of ideas and technologies become plausible and things that we can do today. There is just still significant push for that elusive quantum computer that solves all of the problems of the world. But even those, even theoretically speaking, they are going to be very useful for very very specific applications. They're not going to be like completely replacing the computers. So I'm excited to see where it goes, but it's the usual hype cycle that we're seeing.
Yeah, absolutely. I mean, going back and diving into that, like I know a lot of principles have been utilized, especially in biology, right? Like the blend of technology and computation and biology has changed things. Recently, one of the top of mind project problems for us is the idea of immune drug resistant bacteria and viruses. And recently, there was a supercomputer that was able to devise a drug that can go out and neutralize a virus based off of an antiviral that we would never have designed. Like it built something that's
Yeah.
very specific just for that virus. And suddenly, there's now hope that we have this new tool that we can now combat our ancient battle against viruses and bacteria in a new front instead of and moving drug discovery from just accidental discovery and finding out what nature already has to creating complete synthetic tools for that. There's also the component of like protein folds. Like we still don't understand how protein folds, and there's such intricate complexities, and how biology kind of works at that micro molecular level that now is coming into interplay. Right? I come from a neuroscience background,
Yeah.
and the brain is thought of as a supercomputer, as a computational problem. And one of the people I love to follow is Ray Kurzweil, who thinks that we can solve the mortality, or and make people immortal if we can just recreate a digital version of the brain. And
Mhm.
they experimented with creating a digital version of the brain that can compute at the same level. And I think the experiment was they recreated the neural network of a worm.
Mhm.
I think like 65 million neurons recreated in a digital format, and
Right.
they got everything working together. But when everything they turned the software on, nothing happened. Like there was no spark of life. There's no spark of things going on. And now they're like, wait, is this more than a computational problem? It opened up the doors for that. So computation. When people think of this, they think of this, right? Like a platform where you can game, or you can interface other humans, or communication. But really, there's a lot of deep tech involved when we're able to computate at wide level, at larger levels. What do
Mhm.
you think? And I know you said you're moved away from this field, but what do you think would be like the ideal breakthrough technology, that quantum computing or an abstraction above of computation that we have now? What do
Yeah.
you hope to see that when you talk about problems that could be solved with from the
Yeah.
quantum side? What do you envision?
Yeah. I mean, the honestly, I think the biggest challenge that has to be solved in quantum computing is the hardware side, because without hardware, we can sit down and imagine all sorts of algorithms. And if you have nowhere to run them, they're cute science fair projects, right? So ultimately, if you're talking about impacting the real world, uh, we do need hardware. However, very much like how NASA was trying to do whatever, and they ended up creating, vacuum cleaners, or they inspired the vacuum cleaners, etc., microwave ovens, etc. That's what I'm hoping that will happen in our chase of, quantum computers. Like we might try to aim for the moon, but land shorter on a lot of quantum inspired algorithms and techniques that are classic. They're plausible to run on our usual machines, and still do a lot of interesting use cases. I think when we talk about computation and a lot of interesting things that we can do, I'm also very excited to see how far we can push machine learning and deep learning, because one of the very, very fascinating things for me moving from quantum computing to AI was the fact that the fact that quantum computers are so hyped up is based on a conjecture that we don't have any good classical solution to a bunch of problems that they promise to solve. But the reality is, do we actually not have a solution to those problems? And then all of a sudden, deep learning comes along and says, well, actually, for a lot of these problems that, for example, protein folding is a very good example that you said. For the longest time, we thought, okay, this is an extremely complex problem. This is probably going to take us forever to do on classical machines to even simulate it. And we definitely need quantum machines because, well, this is a quantum system. You're talking about molecules. But then all of a sudden, deep learning comes along and say, well, actually, if you don't care about an exact solution, I can approximate it pretty well, and I can do it pretty fast, and I can get a pretty accurate response, right? So that's a very, very interesting, twist in this story. Even like today, I'm thinking, okay, I mean, as an intellectual exercise, it's great, but all of the other things that is inspiring are also great. So maybe we should also spend time thinking about those. And I think a lot of people are doing that. A lot of people start by theoretical ideas, and then when they ground themselves in the applications, then they see a lot of interesting things to work on. And I think for me personally, I talked about moving on, and the part that really fascinated me was the example that you gave, like the fact that today we can computationally predict things that scientists would have normally done in the past, right? And the part that is fascinating for me is that we can do that on language, for example. Like we can, the product that we are building, part of the vision of it is we just feed it scientific papers. It reads all of this, does computations on it, finds interesting and surprising connections between these different types of concepts, and then essentially guides you to essentially come up with better product ideas, right? So there are a lot of interesting things that we can do if we just reframe the problems a little and mostly ground them into, what is it that we can actually build with the hardware that we currently have.
Absolutely. One of my so I got my deep love for science through my dad, who used to come home with like Scientific American uh, magazines and like challenge
Yeah.
me on ideas like, oh, what do you think about this? What do you think about that? And I remember one of the coolest things I thought as a kid was like black holes, right? Stephen Hawking. I remember like Stephen Hawking's theory of black hole radiation came into play, and it was a theoretical model that he built that showed that black holes actually lose mass over time, and we weren't able to prove that until like years later. And I thought that was like such a fascinating thing that theoretically you can mathematically build models, and that's what math was, right? The ability to simulate things, real world events, and how the universe works under certain laws and conditions. And you can do that. And now with computation, with the latest breakthrough of they built a simulation of a black hole, how it works, and the amount of computing power and programming required for that, right? Like the disk of hard drives that was standing there, right? It is required to get that point. So it's like we're moving from an abstraction of mathematical laws that have to be, calculated or and devised and abstracted from mental models to now computation that can run these kind of live events. And I think there's gonna be a point where like, once we have like 3D monitors and like you can simulate environments and like you can teach kids like this is how the molecular your body works to like this is how the
Right.
universe flows and functions, and this is how fluid dynamics works, and things can kind of come move from a state of abstract to more
Right.
like reality state of play. I think that's going to evolve humanity at a certain point where now we can like play with our environments and see how things interact and work in a real time kind of a visual with the visual complexity. So going back to that, like I want to dive, the idea of computation with data, especially big
Mm.
data, and
Right.
this concept that's coming from the mechanical engineering side of digital twins. Right
Mhm.
now, we're creating these digital twin simulations of how the universe works, to simulation of how the world works and how cities flow and function. I grew up playing these kind of games like SimCity, where you can
Yeah.
create a game and you can see now where the water flows, and you can predict based off of more humans come in, what are the flows and demands, and these simulations kind of changing. And there have been companies that came on the show like 3D Cityscapes. It's a great company that
Mhm.
came through our network, and they build twins of entire cities. They're right now recreating all of Dubai in
Right.
preparation for, I think, the World Games, and they can now simulate based off the influx of people coming in, what are the demands and logistical curves that's going to change. So computation, adding to that complexity with big data, can actually change how we kind of manage ourselves, as society kind of manage ourselves. And now with our strains, with our supply chain and agriculture, being under assault, I think, like, because we had like a great weather event this year, we actually a lot of people did not starve. Like, our supply chains broke down. We are low on phosphorus. We're low on these nutrients that we can get into our farms. But because we had a good year harvest wise, we were able to survive. If we don't have that next year, they're predicting that it's going to have a catastrophic effect and food supply and things like that, right? So data and manipulation of data, and visualizing of data, and accessing of data can allow for now widespread holistic planning, where we could go and what kind of difficulties we can face. I'd love to hear your thoughts. How are you thinking about data and big data, and how has that transition been from computation to data and software?
Yeah, definitely. I mean, as you're saying, this is a universe of data now. Like there are all sorts of different ways that we are interacting with data. Even we've been doing science with data for years and years, and now we're moving to a space where, as you said, the classical models of simulating the universe and how we interact with it is getting a lot more intertwined with things that we don't even have necessarily theories for, but we can collect data for it. And then there's always this interplay between how we understand systems work and how we can generalize our understanding, and what kind of data we can actually collect. So there's definitely a lot of interesting things that happen there. But I think what I'm most excited about is really doing that sort of thing that you're talking about, like creating digital twins, but not in the metaverse sense. Like, what I'm very, very interested in is how can we create digital copies of our brains, not in the sense that you said, like a complete replica and chasing consciousness and all of those good things, but rather let's focus on a very, very specific functionality of our brains, which is the memory and its ability to reason, right? So can we essentially teach machines and come up with system designs, architectures that use AI and data and all of these good technologies to create a replica of our ability to consume, for example, technical information and the decision processing that goes into software design, for example, right? So the way humans do it is that they sit down and search things and find a lot of documents, read these documents, and from each of these documents grab a piece, like a GitHub repository where you copy paste a bunch of code, a bunch of scientific papers when you get inspirations for things you can try, a bunch of YouTube videos that you watch to understand how different algorithms work, and you're just sort of in your head piecing all of this together into some software that design and build. Can we teach machines to do that, right? So that's what I'm very, very fascinated with, because that brings together a lot of very, very interesting cognitive capabilities that our brain has. A multimodal consumption of information, like reading text, analyzing audio, watching video, and all of these form an understanding of the world, and based on that make decisions about, okay, I'm trying to solve this specific problems, how can I do that? So that's what I've been very, very fascinated with over the past few years. And I've seen all of these futuristic kind of experiments of trying to replicate a brain. But as you said, that's extremely difficult. We are nowhere close to understanding how that can happen. But very specific functionalities of brain, you know, we are closer. Like still extremely ambitious, but we are much closer now.
Yeah, I'd love to dive deeper into that with you because one of the key things about technology and the rise of technology is solving for is the fact that our brains can't grow any larger than it is. We've became a fixed, we're in a fixed kind of state. As mammals and as primates, more women die, per capita from childbirth than any other primate, any other mammal, because of our heads. Our heads have gotten so big that going through the birth canal can, cause damage. And if it can't grow any bigger. It's one of the main reasons why human children, spend so long in infantile dependency on parents and mothers, because we take 2 years to develop outside the womb, where the brain and the head is actually enlarging and reforming, and the skull plates are changing, right? And that's been evolution's kind of fixed because it can't make the brain any bigger, so it creates an external environment for it to grow after the fact. But even with that factor, we can only grow and develop so much. One of the things I was shocked learning in my neuroscience classes is like where the neocortex is just like a thin layer on top of the brain, and that's one of the reasons why our brains are so much crevices and
Mm-hmm.
things, because to create more surface area for the neonatal layer, and that's where really our superior cognition comes from, right? The prefrontal cortex came for the primates and allows us to for some levels of cognition, but the neocortex is what's unique to us, and there's only so much room for us to grow, and so much curvations the brain can go through to expand that further. So it's almost seen as like technology will be able to augment our cognition, augment and grow our capacity to think and develop and learn through external additions to the brain. Have you put any thoughts into this and what this kind of state of play could look like?
Yeah, almost every day for the past 4 years. Uh, so one way that I like to think about what we're building is a tool for thinking. You know, which is which is kind of what you alluded to, like the fact that our brain's capacity, like that's literally the third slide on my pitch deck for my startup. Our brain capacity to consume technical information is just not changing. Like that's what it is. So the only thing that we can push us further in our cognitive ability beyond where we are is, integrating and collaborating with machines. So integrating can mean many different things. Elon Musk thinks that it is a chip on your head. Ray Kurzweil probably has his own narrative there, but a more realistic short-term view of that can be, the ability of humans to collaborate with machines. So there are a lot of human computer interface, like HCI, ideas that people are exploring, where exactly that's exactly the idea, where your capability expands. Like it could be your physical capabilities with Boston Dynamic, you know, accelerators, or it could be in our case with, a machine that tries to understand what kind of knowledge you're trying to acquire and consume and compile, and then guides you through that process. So these human machine collaborations and interactions is definitely a very, very interesting path forward. you know I know a lot of people are very worried about machines taking over and all of that, but maybe that happens, maybe not. But between now and that potential outcome that we don't know what it is, there's a lot of opportunity for us to collaborate with machines, to have machines, to design machines that augment our capabilities. And augmenting our capability to think, I think, is a very, very interesting part of this. We have AIs today that help marketers write better copy. Like you just give it a prompt, it just writes a paragraph for you, you edit it, you publish it on your website. We have AI that keeps track of soccer matches, gets all the stats, plugs it into using computer vision, gets all the stats, plugs it in, and sensors, plugs it into template, as a sports reporter, you go through, read it, you add a few things, and you publish it, right? Then you have the new art, the new generative art kind of AI, DALI, that has come out recently, where you just prompt it and say, dog swimming in whatever, and it just gives you an image of that. So as an artist, you can grab that. It's probably technically right. You just add a bit of creativity and publish it. And continuing on the same trend, it is very, very imaginable, as you gave an example in biotechnology. We have algorithms that can read data and help us design drugs, that can help us design other types of things like material. That's a very, very huge area too, like automated material discovery. And then we are interested to take this even a little further and say, any complex problem that you want to solve ultimately is understanding a bunch of different technical concepts, how they relate to each other, and how you line these up to create a solution. Can we create data sets that teach machines to do that? And can we create products that essentially collaborate with human users, human agents, to essentially carry out these very complex tasks much, much faster?
I would love to hear your framework of how you think that'll work. Because like we're the state we're in right now. I think one of the main reasons people feel distrustful of technology is that they have no ownership of it, right? I had this like very lucid conversation with somebody, and I was comparing like the state of technology right now almost to like the ancient myths of ancient peoples, right? The idea of like these like these algorithms and AIs and tools we utilize around us are almost like these like celestial intelligences, right? We don't see them; they're ethereal, but they exist. We know they exist, and they have impacts on us, right? They push and prod us in certain ways. Our Instagram notification, Instagram has multiple intelligence working and working to like engage us on that platform. There's other apps, through our phones working through us, for our technologies working for us, trying to gather for our attention. Now there's smart speakers, smart TVs, yeah, and displays when we go to stores that are constantly working to gather our attention. And the attention play is a worrisome part, because now these intelligences are learning from us in order to pull us towards certain direction, and the benefit of that is ascribed to fewer and fewer people, right? So the concept that the intelligences that we create will go out to benefit a very few people, who then ultimately use those intelligence to subjugate the rest, and the ultra rich become like godlike figures with now high
Yes.
leverage over those who cannot afford to catch up to them, is a constant fear, right? And I think
Mhm.
there's three quintessential areas where technology can take us, right? That idea of technology being able to subjugate us, the
Yep.
idea of technology revolting against and going against us, or maybe even become like almost like like put us in a servitude where we're in such a docile state because we're being serviced by technology all the time. Like, food comes to us. This thing, everything is service. The infrastructure is built to service us so much that humanity doesn't attempt to do more, and become lulled. Or what we're kind of talking about here is like the individual becomes empowered, and now we're working at an abstraction above, and technology and intelligence can work for the individual. And I think that's where Web 3.0 is really exciting to people. The idea of
Mhm.
ownership. We can own our data. If we can own our data, then we can own the algorithms that work on top of that data. And I think this is where the hope comes from, and why a lot of Web 3.0 companies, exist in this kind of myriad of hope, is that idea that technology can ultimately be used for the individual rather than used for the few against the many. What are your thoughts on this? What do you think as a framework for how technology can be utilized to intellectually augment us?
Yeah, I mean, what you're saying is true and very plausible. And to me, there is a significant difference between what we can do and what we should do, right? And that's the overlap, or interplay between technology and governance normally, right? So governance usually comes from, well, governments and other types of authorities. And normally governments are at least a decade behind where the frontier of technology is. But at least the good thing is that they're finally catching on and saying, "Oh my God, like, this data can be disrupted. This data can change the election results. This data can, impact people's decisions. You know, mundane things like buying this shirt versus that shirt, all the way to, who's going to be the president of this country for the next 4 years, right? So when events like this happen, governance tries to catch up, and that's where there is a bit of hope. Like, governance becomes smarter and tries to catch up. But the reality is that it's always going to lag. So the ideas around Web3 is interesting because, they also try to distribute governance. So I'm excited to see, Web3 DAOs and, that kind of ideas that try to decentralize decision making and reaction to the movement in technology to a level where, a group of people can quickly come together and say, wait a minute, there is this dangerous downside. What kind of guardrails do we need? But regardless of what will happen in the next few decades in DAOs and, decentralized ideas, I'm very, very interested. I'm keeping a very close eyes on decentralized sciences specifically because, what we're building is ultimately, our vision is to be a decentralized knowledge economy, a marketplace where people contribute knowledge and get compensated for it when it produces business value. So, something like that needs to have governance. So I'm keeping a very, very close eye on that and see where it is going. But even in the meantime, there are a lot of very interesting things happening beyond just decentralization. For example, a lot of ideas around private AI, differential privacy is an example of that. I know companies in Toronto that are specifically working on enabling companies to redact the data that they should not use, like the names and faces and all that, right? So, and there are other ideas like federated learning, which is very similar to, the ideas that blockchain is promoting, but, in the space of something that we can do right now. Essentially, data can exist where it is, and we want to do a central computation on it. We just take the parts that we need. And then in the decentralized world also, we are talking about all of these, zero knowledge proof kind of ideas where you just take what you need and answer a question and move on without, just saving data about every move that you're taking, right? So this is ultimately, I guess, the short answer is that it's always an interplay of technology, self-correcting technology, and governance that will essentially happen. I don't know what the outcome will be. Like, it might be, machines taking over or whatever. But, that's very hard to predict. And there's actually a very good book called Super Intelligence that goes into a lot of details about potential futures. But what I know that we can do, and we are kind of trying to do today, is to think about all of these potential, edge cases and think about, okay, these are the guards and rails and balances that we need to put into place, even from a technology point of view, enabling developers to think about these and, take care of these, because we know that the governance is not catching up properly. So excited to see how all of these will play out, but there are a lot of cards on the table, and hard to say which one will take over. But I assume the solution is going to be a combination of all the above.
Yeah, I really love what you said there, especially about super intelligence and the coming futures. The thing with that book is that it focuses a lot on society itself becoming super intelligent.
Right.
The aspect is like where does the individual fit into this, right? That's why I think why Elon Musk captured the imagination of so many people. The idea of an implant going in that can biologically allow you to like interact with the internet and therefore access technology seemed like a possible way of the individual becoming superpowered rather than systems around us, right, becoming superpowered, because that is the fear. Because then who owns the systems, who runs the systems, and then the systems can be compromised, right? So coming back to your idea of like the brain, of data, of computation, do you have a framework for how you can improve the individual's capability of cognition?
Yeah, I mean, what you're saying is a very, very interesting topic, and I have spent some time thinking about it. Like, what is even the definition of individual in the world that is coming up? Because especially if we manage to connect all of these brains to each other, then what is the definition of self? Because I don't know if you've read The Man Who Mistook His Wife for His Hat, or very, very similar books that talk about how a lot of the functions that we take for granted that define self and consciousness are just essentially brain functions, and very specific brain areas that if they are damaged, you lose that part of self-awareness. If our brains are connected to each other, then what does self even mean? What does individual even mean, right? And even not going that far in the world that is coming, that everything is connected to each other through data, and phones that are probably the preamble of that brain on that chip on the brain. Even the definition of individual is becoming a little blurry. So that's in its own a very interesting topic to go down a rabbit hole on. But specifically for what you said, I personally don't know the answer to the question of what the definition of individual will be in the years that come. Especially, as I said, I one of my very strong predictions is that there will be very, very close collaboration of humans and machines. And if the machine is playing the intermediary, either as a chip on a brain or an actual external laptop that is sitting in front of me, I'm collaborating with it. And then this machine is enabling me to collaborate with you and a few other collaborators, right? Like, we are essentially, the machine is facilitating us functioning as a unit, which is a much more, coherent definition of a team than what we currently have. Because when we say a team right now, we are kind of sort of try to have processes to work collaboratively together. But when a machine is collaborating and is advising, facilitating all of the interactions, we're much more likely to function as a unit, and then we achieve our goals as a unit, right? So, what's the framework to make this happen is that usually when we are creating, the ideas are a combination of a bunch of other ideas that we have. So now, if we are working as a team, it could be a team of one or a team of many people. Usually what happens is that when you're brainstorming with somebody, what is happening is that you're coming up with concepts and the relationship that these concepts have to each other, and then you're throwing a bunch of ideas and you're saying, oh, okay, so in my mind this concept was related to this other one, etc., etc. And as a unit, as a group, we come together with a mind map of these are the ideas that exist, these are how they relate to each other, and then we start reasoning on that. We say, okay, what if we tried this, what if we tried that? I've seen this relationship happening, this other system, can it work here? And then we tried, experimented, and achieve, collect some data about the experiment that we did, and feed that data into the design that we did originally, and just repeat doing that until we find a solution. So essentially that collaboration, that empowering individual, is coming from a lot of us collaborating together. But the very, very fundamental piece of it is creativity, innovation, and creation is often not out of nowhere. It is often out of ideas that we already have, either in our heads or written in our notes and text and textbooks, etc. So now if the machine can take care of keeping track of all of this, and show us the most relevant pieces of information as we are brainstorming, as we are designing, as we are building, then it can empower us to do that much faster and with much less error. And that's really the fundamental framework on a super high level. Have the machine do the accounting, do the ledger of this is the knowledge that we have, and this is how all of this is related to each other. And we, as the agents and operators of it, as the collaborators of it, we just work with it and say, okay, yeah, this part is actually interesting. Can you connect, find all of the things that are relevant to it? And then you come in and say, oh, I see what you're doing here. How about this one? And this collaboration between machine and agent keeps going until you have a design that we can actually use. So again, like, this is super high level, but hopefully that clarifies a little where I'm going with this.
Yeah, that's interesting. I mean, I especially like the idea you said. I talked about the diffusion of self, right? Like, of what that means. And there's been a lot of thought around this, especially with psychedelic research, actually, right? So, I mean, starting with the Roman Empire, the Roman Empire, had this unique problem of growing too fast, growing too big too fast, and now having millions of people from different ethnicities and backgrounds across three continents that had to, it had to, you know, they had to sell the Roman story, that we're all Rome, etc. Even though ethnically and biologically we're coming from different backgrounds, and they used to use psychedelics. They used to get, have these themed parties, multi cities from the state downwards, provided where everybody would, be induced at the same time in order to let go of self and feel like they're part of something larger and something bigger. And that was ceremonially used by the state in order to drive, right, this idea of collective consciousness. And Huxley, in his book Brave New World, talked about the merger of technology and psychedelics and drugs, and particularly in doing that, right? So the idea of dissolving the self, so you feel like you're part of something larger. Therefore, you're letting go of that individual need to hold on to need to things, and you contribute to a larger vision, to a larger self. And a lot of tech companies are built upon this kind of idea, right? I think DreamWorks and Pixar are famous for using, I think, LSD in order to like think differently and visually create better and drive those kind of things, even though it was not deemed necessary. But now, as like psychedelics seems to be coming into the forefront, becoming decriminalized, becoming the forefront. I think a lot of tech companies are using this, seeing this as potentially the solve for how to blend man and machine together. For example, they're thinking that VR and AR, all right, and the idea of creating immersive worlds could be enhanced using induced states, where you be going to a self where you dissolve the state of self, where these virtual environments seem just as real, or you kind of merge into your reality, and therefore you can have these blended realities exist within the self. So I find that to be fascinating as well. I know it's moving a little bit away from the idea of computation, but has that come into your realm at all?
Oh yeah, I mean, that's this conversation is becoming really interesting. So um the idea, I don't know if you probably have read books like Blink, Art of Choosing, Thinking Fast and Slow, etc., where all of them talk about this 95% subconscious cognitive abilities that we have in figuring things out and doing stuff, right? And a very, very interesting consequence of that is the fact that as society, as humans, as Homo sapiens, our ability to keep track of things is very, very limited because our brain capacity is limited. And normally, the way we go beyond that is by creating cultures and memes and things like that. So the example that you're giving is one way of achieving that, coherent behavior and mass action about something. Uh, but traditionally over the years, we have done that through ideology. We have done that through religion. We have done that through governance. And now, the new type of religion that we have, which is capitalism and tech and all of these things, are essentially doing the same thing. Like the function of all of the above, regardless of the utility, is to enhance the capability of our brain to do something as a very, very large unit. This large unit can be a nation, could be a city, could be a neighborhood, could be people in a company, could be anything else really. So it could be just a team inside a company. So our ability to function as a team could be utilized by very, very different things throughout the history of mankind. 10,000, 70,000, well, most probably down to 70,000 years of recently, well, we have the cognitive ability has been mostly through stories, and probably in the past 5 to 10,000 years have been through substance enhanced as well. But recently, we are achieving the same thing through technology, right? Like we have seen a lot of examples of this, like all of these revolutions that happen in companies that are, sorry, in countries that are completely driven by technology, people just moving in accordance to each other because everybody knows what everybody else is trying to do. And that's the same that is happening in companies. And that's exactly the direction that I'm talking about as well, like where there's a bit of a black hat, white hat kind of scenario here, right? Sometimes you can use that to mobilize people to do crimes, invade other countries. But sometimes you could also have the white hat version where you mobilize people to do charity, to do good, to build something that pushes humanity forward. And hopefully the version that I'm promoting is the white hat version, where the technology enables us to mobilize hundreds of people to innovate together and solve climate change, or cancer, or protein folding, or all of these other things. The idea of networked science is a very, very interesting topic. There's a book called Reinventing Discovery that goes into a lot of details about it, and I usually say that that's a major inspiration of what I'm building. But the ability to network brains, not literally, but through process and technology, and enable a lot of people to innovate together towards a common goal, be it through substance, or pure technology, or culture, and most probably a combination of all the above, is exactly what I'm talking about. Is exactly the objective, is exactly the objective of that decentralized knowledge economy that I was talking about. So that's 100% the right direction.
I love that. I feel like there's like a few more tangents that I would love to chase, including especially how language, is transforming our culture and society. Like, just because how we communicate fixates on how the technology we use. If the English-speaking world uses technology that's different from the Mandarin-speaking world, different from the French-speaking world, different from the Spanish-speaking world, and the idea that we're fracturing into super states based off of language, like the Anglosphere, the Francosphere, the Spanish-speaking sphere, the right Mandarin-led sphere, is that's globally we're becoming into states. So it's through the digital, to our digital infrastructure is coming into play, and how potentially the rise of NLP and language processing machines can help bridge those gaps at a better level, right? So we don't necessarily have to understand each other, but if you have a middle person that can live translate, that can provide these kind of functional transfers of knowledge between cultures, now suddenly we can finally elevate from those super states into something even grander, even larger, and allow for knowledge transfer between units that might be doing the same things but not being able to interface just because of the incompatibility of language. So coming back to that, I really would love to spend the last 5 minutes that we have together talking a bit more about your initiative. So this idea of community-led, self-organizing knowledge and navigating through that. What does that look like, and how can people interface with it? Can you talk a little bit more about your company?
Yes, definitely. So this is yet another very, very interesting topic that I sometimes give talks about. The again, like piggybagging on what I was saying earlier about cognitive revolution. One of the most interesting things that happened about 70,000 years ago was that sapiens gained the ability to tell stories. And usually to tell stories, uh, to have imaginations and tell stories, you use, eventually we started creating tools, and that tool we call it language, right? So and we use language to create shared experiences and shared knowledge, like usually. And language could be drawings on a wall in a cave, or spoken words, or spoken tunes, or whatever version of it that you can imagine. But ultimately it's a tool for us to share information and knowledge and experiences, right? So when you think about it that way, the reason that people in Iran talk to each other in Farsi or other languages that exist there, and people in Canada talk to each other in English and whatever, is that that's the common contract that they have. That's the tool they chose to use. But now it becomes very interesting if you start thinking, okay, all of these are tools for communication and interaction and sharing experiences and knowledge. Is there a common ground, a middle ground, where we can translate all of these into something that everybody understands, right? And if that something exists, then it is, you can imagine going from one to the other very easily, from English to Spanish, from, I don't know, spoken words to images, from etc., etc., right? So, and that common denominator is something that deep learning has given us. But there's this concept of representation learning, and natural language processing is one example of that. Is how you can grab whatever the tool of communication is and transfer it and translate it into numbers, into vectors, and then that vector represents that idea, not the words. It represents that idea. In an ideal world, of course, right? In an ideal world, you can come up with numbers, list of numbers that represent an idea. And if we can achieve that, then we can grab that and translate it into Spanish. We can translate it into an image. We can translate it into a movie, etc., etc. Right? So that's the power of language that we're talking about. Our ability to grab a tool of communication in any format that it is, translate it into something that everybody understands. Interestingly, including machines, because machines can read numbers and vectors, right? So then we can do a lot of interesting things. So the idea of this technical shared memory that we have is, especially technical knowledge, is shared usually through written language. Like we just write things, write scientific papers, like technical blogs, write code, etc., etc. So all of these are written ways of doing language. So can we do natural language processing to capture and extract the pieces of information, the pieces of knowledge that are very, very interesting? Say you want to take a new mortgage, right? You don't know what the process is. It's a complex process. You have to bring together a bunch of different pieces. Have no idea where to start. But what you know what to do is to go to Google and start, saving a bunch of web pages and read a bunch of forums and talk to a bunch of friends. So what if a machine can sit in the middle and keep track of all of these and analyze them and then visualize that, okay, you've looked at 50 web pages, you looked at 62 forums on Reddit, you had all of these text messages with your, friend Ravi, and etc., etc. And here is a visualization of the knowledge that you have. Again, like we turned it into vectors, right? Now I can turn it into any other forms that I want, and I can visualize it for you, literally show you this is the knowledge that you have. And then if you can interact with this knowledge, with this graph, and then I show you, okay, you're interested in mortgage rates and the nuances that it has for the neighborhood you're interested in. Here's a conversation you had with Robbie about it. You don't need to remember that you had that conversation. And then under that, here's a forum, here's a subreddit that was talking about it, and this is the conversation about it. So you start interacting with your knowledge in a way that is not trivial. Like you don't even need to know that, okay, in this very moment, I'm interested to know how mortgage rates relate to neighborhood and how that relates to whatever else, right? You can just literally click on the graph visualization and find those pieces of information that are necessary for you from what you have seen. But also we can go beyond it. We can even recommend you that, oh, okay, so if you're interested in, there are all of these other conversations that you probably missed. So take a look at these as well. So that's the idea, like the idea of enabling you to keep track of all the pieces of knowledge that you need to make a complex decision, visualize it for you, allow you to interact with this knowledge in a way that is non-trivial, and then help you to use these pieces of information to essentially put together your puzzle. The puzzle of getting a mortgage becomes as easy as finding a bunch of information, dumping them into a system. It analyzes you and guides you through essentially your design journey.
That's fascinating because like that goes counter to everything that we're living through right now. I think one of the main components is like, and I want to end with this the thought of how why is so powerful what you're talking about is the idea. I think Scott Galloway wrote this in the Big Four. The idea that four organizations, Facebook, Apple, Google, and Microsoft, have within them 700,000 of the top thinkers and minds in the world. And and previously in the previous generation before, the Manhattan Project, containerized 300,000 of the top minds, and they were able to produce the nuclear bomb. Right now, 700,000 of the top PhDs, the researchers, all thoughts are going into feeding ad-driven models of understanding people, so they can remarket and retarget that. And even people working within the infrastructure are so frustrated that this is what we're deploying technology and computation towards. So this idea of augmenting our capability with a with an intelligence that can learn what we're learning and abstract from that and revisualize that and guide us towards the path that we need to take. That is so fascinating. I am going to go check that out. This is an app? Is this a tool? How can people interface with it?
Yeah, so it is a web app. Currently, we have some integrations, for example, into browser, so that when you're researching and you see interesting pages, you can bookmark them very easily into our library. We have a Slack app that is coming out, but ultimately, all of these is a library, a web app that you can collect all of the information that you're looking for. We are Our graph navigation is in private alpha, so if somebody is interested, they can reach out to me, and I can set up their access depending on what their use case is. Um, the website is very easy to remember: AI.science. The two things that I care about
Beautiful.
a lot. I know, I agree. And Aggregate Intellect is the name of the company. They can check that out. And the story of Aggregate Intellect is that I was looking for something that means collective intelligence, but
Mm,
abbreviates to AI. So that's what the name is. And yeah, I'm more than happy to brainstorm with people about what they're trying to use our tool for, and guide them through the experience. But they can definitely check out our website, YouTube, LinkedIn. We are pretty much everywhere. So reach out, and we can talk more.
perfect. I was just going to end with the request for where people can learn more. Amir, thank you so much for spending the time with us here today. I love this conversation. I feel like this can, if I don't stop this now, we're gonna keep on going in different
I
tangents. I'll
know.
love to have you on for a part two, and dive a little bit deeper into this, if and when you're capable. But
Yes,
till then, thank you for your time, and
of course.
I'll see you soon.
Thanks for having me.